In this problem, we will use an experiment with a capacitor and a switch to measure the resistance of a voltmeter. Important concepts we will need include the capacitor voltage when discharging through a resistance. This has the form of an exponential decay. Problem statement tells us that at time 0, a charged 10 microfarad capacitance is connected to a voltmeter. And the connection is established through the switch that closes at time t equals 0. Now once that switch closes, the voltmeter is connected in parallel across the capacitor. So a voltmeter can be well modeled as a simple resistor value. So the equivalent circuit, once the switch is closed, would look like this. Now the equation that describes how the capacitor discharges through the resistance looks like an initial voltage VI times an exponential decay, e to the minus t over RC. You can picture that capacitor discharge voltage like this. At time 0, the exponent or exponential portion is 1, giving us simply VI, and then it drops off until it approaches 0. The problem statement tells us that initially the voltage reads 50, and then sometime later it reads half that value, 25 volts at 30 seconds. Again, we are looking for the resistance of the voltmeter. So we can start to apply some of this information. We would say that the capacitor voltage at t equals 30 seconds is equal to 25 volts. We know the initial voltage was 50. We know the time at which it reaches that half value is 30 seconds. Capacitance is known, so we then solve the expression for R. Let's move on to the detailed solution. After the switch is closed, we can redraw this circuit as a capacitor connected in parallel with a resistor. The resistor models the input resistance of the voltmeter. The capacitor voltage Vc exists across both the capacitor and the resistor. Now when we have a capacitor discharging through a resistance, we know that its voltage across time is the initial voltage Vi times e to the minus t over Rc. The problem statement tells us that the capacitor is initially charged to 50 volts, and then the voltmeter reads 25 volts at t equals 30 seconds. So I'll go ahead and make those two substitutions in the equation. Initial voltage is 50. And at this point we can start to begin solving for the resistance R. So I'll bring 50 on the other side of the equation. Take the natural log of both sides of the equation, and that will get rid of the e term, allowing us to see only the exponent. And I'm trying to solve for R. I'll bring R on the other side. Bring this whole expression to the denominator of the right-hand side. And then substitute in the specific value of the capacitor. And when you evaluate this on your calculator or similar device, you find that the resistance of the voltmeter is 4.328 mega ohms. Well, let's review our problem-solving approach. First of all, we modeled the voltmeter as a resistor, and then recalled the equation for the voltage of a capacitor when it's discharging through a resistor. We used the initial voltmeter reading as the initial capacitor voltage, and then substituted its reading at 30 seconds into that equation. We then solved for the voltmeter resistance.